So e is such a unique function because the derivative of e is e, and the antiderivative of e is e to the x plus c. Okay, if e is raised to some f of x, then we just take the derivative of the function and multiply it by e to the f of x. So we're going to be using this rule throughout this page. So this makes these derivatives very, very easy. Take the derivative of the function of x and then leave it as e to the f of x. Okay, pause the video and do this one. And then I'm hoping that without any work, because we could use u substitution here, and we're gonna, when we get to the more complicated ones, we'll use u substitution here, but I'm hoping you can recognize this is the inverse problem of this first problem. Okay, so how does that affect our answer? All right, so again, pause the video, try this row. Okay, easy stuff here. Okay, over here, to recognize that this is the inverse, notice, oh wait, I'm sorry, I have a typo here. This should be 5x. Notice that the exponent never ever changes. Okay, the exponent always stays the same, whether it's a derivative or antiderivative, but if it's just a constant and we took the antiderivative, then what we get is the reciprocal, because we would have let u be 3x. Take the derivative, you'd get 3, and we know when you find du dx and get 3, it always ends up as a 1/3 out front. I don't know why I'm writing equals, I mean to be writing plus c. Okay, so if you can do this problem, then it's not a stretch to say that this would have to be 1/5 e to the 5x. And you can tell you're right because if you took the derivative of this, right, where you drop the 5, right, and then left e to the 5x the same, you'd get back to this, right? Taking the derivative of here, these 5s and these 3s would cancel out and you'd get back to where you started. So let's get just a little bit more complicated. Actually, let me jump down though to this problem, which is not more complicated, but it's a definite integral. Okay, so we should recognize the only difference here is that after we find the antiderivative, which would be 1/6 e to the 6x, that we have to plug in and use the fundamental theorem of calculus. So plug in 2. And then, so you're finding f of 2 minus f of 1. And I don't mind answers left in fractional and exponential form. Okay, so we're going to plug in, and we are going to get 1/6. I'm going to leave that out in front as I plug 2 in for x. So we get e to the 12th. Minus e to the 6th, and I hope you know you cannot just subtract the 6 and the 12 and end with e to the 6th, right? These do not combine, and that's your final answer. Okay, so this one was really not more difficult. All right, let's do one more of the kind of more difficult ones. I got a bunch of problems here, don't I? So I'll make this again into 2 different videos, but let's start with the derivatives, okay? And then I'll do the integrals in a separate video. So again, I mean, not much more complicated, just because the exponent is something more than just a constant, we're still following this rule up here, right? It's just the exponent's a little bit more involved. Okay, so for this first one, the derivative of this, well, what's the derivative of the exponent? That would be 14x, and I want that in the front. Okay, that should go in the front. And again, I'm really trying to stress the fact that the exponent never changes. Now, when I was on that trig video, I kept talking about the angle never changes, right? Well, the exponent never changes. Over here, okay, so we get e to the 1 over x squared. So this is good review for the final, okay? Because how am I supposed to take, what's going to go here, right? What's going to go right here is the derivative of 1 over x squared. Okay, so let me come down where I've got some room and find the derivative of 1 over x squared, which I should know. Bring this upstairs. Okay, and we've got to remember we're doing derivative, not antiderivative. Okay, so derivative, drop the power in front, decrease the power by 1. Right, so these look like problems from a quiz way back in like early October. Okay, then the -2 stays upstairs. The x cubed comes downstairs. So good review for your final to go back and do some of these derivatives that we were doing earlier in the semester. So that's what goes in front of the e to the power of 1 divided by x squared. Okay, because there is the derivative of the power. Okay, so I'll end the video here and then I'll come back and we'll do some of these more difficult problems with U substitution.